Hi, 12. Just thought we'd run through the answers for the questions, the second set of questions. Generally, they were done to a good standard, but there's a few things I definitely want to pick over. So the first question, which I think a few of you didn't actually show me in your upload, but for this one, it's a kind of question that you're very likely to get in exams. So it's testing stuff beyond infrared, but this is how it's often going to come up. It's not an actual AQA question, I believe, but it's very similar to what you'll see. So just looking at the spectra, anything to the right is fingerprint, so can't use that. This is fairly obviously a carbonyl with the just over 1,700. These are just CHs. Now we then need to work out the molecular formula for the molecule, or first the empirical formula for the molecule. So we take the percentage by mass and divide through by the MR. So 66.7 for the carbon divided by 12, just 11.1 for hydrogen, and 22.2 over 16 for oxygen. So we get 5.558, 11.1, and 1.38. So first thing I'm going to try is we'll just divide this through by itself. So divide everything by 1.38. And this does come out to some reasonable numbers. So we get 4.05, 8.04, and 1, and that's close enough to whole numbers that we can assume that is 4 to 8 to 1. So our empirical formula is C4H8O. So then we'll try and match those two things up with each other. So the first thing would just be to consider if you take the CN H2n plus 2 rule for alkenes, that would be in a fully saturated molecule. How many hydrogens would we expect? So we'd expect 10. Now we're 2 short from there, so we've got 8 rather than 10, which tells us we've got one double bond equivalent. So that can be either a ring or a double bond. And just matching that up, we've got our CO double bond, so that's our double bond used up. So it's going to be some 4 carbon carbonyl. So thinking about that, we can have either, so we can have butanal, we can have butanone, or we could have the branched aldehyde. So that is methyl propanal. Now, you can't, with the information you have here at A level, you can't distinguish which one it is out of those. So just with the A level knowledge, you can't take this any further. It doesn't ask you to go any further. It just wants 2 possible structures, so you can have any 2 of those. Something that can come in useful with some knowledge that's above A level. So you're not expected to know this. And it won't get you any credit if you note it down in questions because it's not on the specification. But it's something that does show up in some of the questions, and if you have it kind of up your sleeve, it can help you solve some more difficult ones. You can't put it down to justification, but it does help. It does help solve things. So sometimes when I'm looking at the questions, it's a little bit of information I'd spot, and it would help me solve it. But then if I was to write an answer, if I was doing the exam, I wouldn't use that as my rationale. I'd use only A level rationale. And that's the difference between an aldehyde and a ketone on infrared. So this is a ketone. We've got the carbonyl and the CHs. An aldehyde, you've got a CH bond that's different from all the others. So all of the CH bonds in the ketone, they're all fairly similar to each other. They're just normal carbon hydrogens, very similar to an alkane. But in the aldehyde, you've got this carbon-hydrogen bond, and that's quite different from the others. And it shows up separately on the spectrum. And how it appears is a pair of peaks, and it always comes a pair slightly lower down. And so if this was the aldehyde, we'd expect to see a pair of peaks, somewhat like what the NH2 group looks like. They're normally actually pointier than this, but they show kind of about 2,700. They show as a pair of peaks here. I don't think any of the other questions have that in it, so I can't show you a real spectrum. But that's something you can look out for. And so because there's the absence of that, I know that it's going to be the ketone, it's not going to be the aldehyde. Okay, moving on to the second set. And this one was generally done fine. The only mistake really was some misidentification of this group here. So just with the first one, this is the OH of an acid. We've got the very broad peak centered around 3000, maybe just slightly below, and then we've got the CO double bond that corresponds to that. So that's going to be compound A, the only one that's a carboxylic acid. Okay, so the second one, I think some people have misidentified this as the OH, it's just the CHs, and then we've got the carbonyl. So this one, because of the absence of anything other than a carbonyl, we can say that this one's compound C. So for A, we'd expect to see the OH, which we see there, and this one we'd expect to see an alcoholic OH, which is what we see down here. So this is the OH of an alcohol, not the carbonyl. Nice and simple to match up. So this one is compound B. So the order is A, C, and B. Okay, over the page to the one that's headed with question 8. So this one, I think some people again misidentified this as an OH. It's got to be much broader than that. This again is just CHs. There's nothing for 1700, so this one doesn't have a carbonyl group. So that will help narrow us down. So this can't be B, but we can't. It also doesn't have an OH, and so we're leaning very heavily towards C at the moment. The second one, it's got an OH. Clear, broad, so U-shaped, centered around just below 3,300. So that's telling you it's an alcoholic one. And the only one that we can see out of these that has an alcohol group is compound A. So we can be very confident that that's A. And then the last one here, these are just CHs again. This one here, very pointy peak. This one is it's very high for a it's really quite high for a carbonyl, but I think realistically we can still make the assignment of that as a carbonyl for this very pointy peak here, and so that one lines up with compound B, and so we've got CAB. Okay, so going through to the last set, which is the sort of assigning a very large number of spectra to the different molecules. They're a bit more difficult this time, simply because you've got many more to choose from. So this first one, this one is 2-pentanone. That's the old name for pentan-2-one. So this molecule here, and all we see is just the CHs, and we see the carbonyl at 1718, and then everything else below we can't assign, it's within the fingerprint region. So our next one, it looks really similar in many ways. So we've got the CHs, and we've got a carbonyl, but you look closely, it's got two peaks, and you will sometimes see sort of like a little peak just off to the side, and you wouldn't normally think anything of it, almost like how there's a little bit jutting out the side here. But because it's split right down at the bottom, that really gives you the indication that it's two of these. We've got two different carbonyl groups that are very slightly different for each other. And so that actually hints at something you'd learn at university studying this, is that you look very precisely at the wave number of the carbonyl peak, and that tells you something about what kind of carbonyl it is. But that is way above A level. And so that corresponds to the only molecule that has two carbonyl groups in out of the set, which is the ethyl 3-oxohexanoate. So it's got both a ketone carbonyl and an ester carbonyl in the molecule. So the next one is propanoic acid. Pretty easy assignment, this one. We've got the OH of an acid. It is very broad, far broader than OH of an alcohol would be, and it's centered around 2,900 or 3,000. So it's further over to the right than you see for the alcoholic OH, like the one we see here. And then that's paired with our carbonyl over there. So nice and easy, that one. Now so this one, although it says 2-methylalanine, it's very definitely not 2-methylalanine. I think that is a formatting error. So this one, we've got the OH of an alcohol. The 2-methylalanine would have an NH2 group, which we do not see any evidence of. We've just got these CHs in here, and there's nothing that we see down until that's in the fingerprint region. I would say we could assign that as a CO, but as a single bond of the alcohol group, but we get no credit for doing that in the exam, and really you should just be saying it's the fingerprint region if you're commenting on that region anyway. Okay, so the next one, I think most people identified this accurately, which is the alanine it has the NH2 group. So we spotted the pair of peaks found at 3433 and 3354. They stick out pretty obviously. So we've got our NH2 groups. These are our CHs. And this one here, some people identified this as a CC double bond. Now, that is not a, if you were just using the data sheet, that's a perfectly reasonable thing to assign, and I imagine a lot of you were looking for where that CC double bond would be, because you can see it in the molecule once you've already identified the NH2. This is not a regular double bonds in here. This is something called an aromatic ring, and I'll come back to that very briefly at the end of the lesson, at the end of the video. It's something from year 13 that you will study. It's not relevant for you at the moment, but I'll quickly brush over it. The CC double bond of like an alkene, which is the ones you will come across, be much shorter, and so we'd only expect it to go down to sort of